Hello and welcome to another mini lesson about propositional logic. In this video we are going to do an example of how we can break down the semantics of a complex formula like the one right here using our lovely truth table example. So how can we use a truth table to figure out the truth value, the possible truth values of a statement like the one given here. So we're going to start with this statement. The first thing we have to look at is what are our basic statements here. We have a P, a Q, and an R, which means that there are three basic truth values that go into this, three variables, right? So we have three basic statements that we have to start with that have that can potentially just be assigned a truth value. It wouldn't be dependent on anything else. So that's what we're going to start with, is all the possible combinations of these truth values. So there's going to be even more than we had for the connecting ones before. So we're going to start out with the case where all of them are true. And we're going to work to the case where all of them are false, right? So you start true, true, true. We're going to leave the first two true and make the last one false. True, true, false. Now let's try true, false, true. True, false, false. Right? And now we can say false, true, true, right? And false, true, false, 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 true, and false, false, false. So if you're somebody who wants to be able to check to make sure you really have all the possibilities, you can read the chapter in the book, and it describes how you can figure out how many total rows you ought to have given the number of possibilities there. There's pretty quick ways to figure that out, but read the book. I'm not going to talk about that here. We're just going to continue solving this problem. So once we have our basic statements figured out, these are the possible combinations, we now have to start looking at our formula again, right? So what's the next level for each of these things, right? So first we have to figure out what not R would be in each of these cases. So let's do that one first. So not R. Right? Given that we know the values for R, we are going to fill in, oof, that's a wonky line. We are going to fill in the values for not R. So not R is just the opposite of whatever is in our R column, right? So this is true, so this is false, true, false, true, false, true, false, true. Right, so that's not R. What's the next level up? So what is this interacting with? It's interacting in this construction. So we're going to put this implication statement in. Q, then not R is our next level. So that's going to be our next column. Right, so Q, then not R means, remember what our implication statement means is that it's only true or it's only false if the one on the left is true and the one on the right is false, right? So only if this is true and this is false will this be the case. So here we have true and false, right? This is true and this is false, so this one is false, right? This is true and this is true, so it's true. This is false and this is false, so it's true. This is false and this is true, so it's true. This is true and this is false, so it's false. This is true and this is true, so it's true. False and false, so it's true. False and true, so it's true, right? So we have two cases where that statement, where that formula, if Q then not R, is false in only two cases, right? All right, so what's the next level up here? What do we have to deal with? All right, so we are going to have to deal with this statement and this statement eventually. But first we have to work out what is not P, right? Before we can combine not P with if Q, then not R, right? So not P is our next column. This is an easy one to do because we're just going to flip the truth value for this whole column. So we have 4 truths and 4 falses, so now we're going to have 4 falses and 4 truths. This gets hard to do on a board like this because the rows get a little bit out of whack, but we're going to just try to do it. So we're not going that deep. All right, so, and then we have and, right? So remember that with logical and, you have to have, this has to be true at the same time that this is also true, right? So those are the only cases where this is going to be true. So our next column is our not P and Q, then not R is our next statement that we're figuring out. And that is going to be, we're just looking at these 2 statements and seeing if they're both true, right? They both have to be true. So this is false because they're not both true. The next one is false because they're not both true. The next one is false because they're not both true. The next is false because they're not both true. The next is false because they're not both true. And then we have a line of truths. Right? And finally, we have one more column to do before we can get in our whole formula, which I'm not going to write out because I'm running out of space here. But it's basically not, and then the rest of the statement, right? So this final not, we have to figure out, right? So all that we're going to do is we're going to take this column with all of this, and we're going to negate all of that. So it becomes true, 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 false, false, false. And that is our answer. This is our truth table that will allow us to compute, once we're given these values, we can figure out whether this whole statement is true or false, right? So imagine we have for these, we have statements like Lisa has an umbrella, and we have a statement like Belle is a cat, and we have a statement like zebras have stripes, right? So based on the truth values of these, we will be able to figure out what the truth value of this is, right? So in a world where we can say Lisa has an umbrella is true, Belle is a cat is false, and zebras have stripes is true, we can look for our case where we have true, false, and true, right? True, false, and true. We can just look that up and go across to the end of our statement and see that our resulting statement would be true. So this is how you use this truth table like this, and how you solve a problem like this, which you will definitely have to do a problem like this on your homework. So cheers.